Question 1. Work out the square root of 2 to the 6 plus 6 squared. For this question, you've got to make sure you actually calculate the part in the square root first before you do the square rooting. You should only apply the square root at the end. That's the last function to apply to the value. 2 to the 6 means 2 to the power of 6, as in 2 times 2 times 2 times 2 times 2 times 2. Given that this is a non-calculator paper, it's worth writing the calculation down as you go, doubling each time to generate the answers. 6 squared is just 36, it's a square number. Now when we calculate each of these, we must make sure that we add them up first before we do the square rooting component. So you can see here 2, 4, 8, 16, 32, 64 represents the successive powers of 2. We already know 6 squared is 36. 2 to the 6 is therefore 64, plus the 36 equals 100, but then you've got to square root it at the very end to get the correct answer, which is 10. There are a few decoy answers, as there always are in an AQA paper, so make sure you follow the rules properly, because some of these may seem convincing if you've done the wrong operations or done them in the wrong order. Whenever you are approaching a multiple choice question and it's just a direct question where you've got to calculate something, make sure you actually calculate it first and then find the answer. It's very tempting just to go and check through each of the multiple choice options, and that biases your decision making, and you can often get the wrong answer by doing that. But here the correct answer is 10. Question 2. What is 800 million in standard form? Circle your answer. When you write a number in standard form, the start number must be between 1 and 10, but not including 10, and the power must be an integer. So that's a whole number like 1, 2, 3, 4. It can actually be 0, and integers also include negatives like -1, -2, -3. Now if you look at all of the answers here, you can see that technically they've all done that already, 6, 8, 9 and 10. So they're already using integers. The real question here is, what is a million itself written as a power of 10? Now a million has got 6 zeros after it, which means it's actually 10 to the power of 6. Now 800 million is actually 800 times 10 to the 6, but as said previously, 800 is not acceptable for writing in standard form because it's not between 1 and 10. If it were to be between 1 and 10, the decimal point would have to move from this location to this location here, as in 800 becomes 8. Now if you've made 800 100 times smaller by making it 8, you've got to make the power 100 times bigger. Now that just means you've got to add 2 to the index on the 10. 6 add 2 equals 8. So 8 times 10 to the 8 is the correct form for 800 million when written in standard form. Question 3. Circle the expression that is equivalent to 4a to the 5 all squared. Now when you apply an index to what is effectively already an expression, in this case 4a to the 5 is the expression and 2 is the index, you've got to apply that index separately to each of the terms in the expression. So you've got to square 4, and then you've also got to square a to the 5. So you do those separately and write the answer as the product of those two values. Now when you do that, you should find that 4 squared equals 16 and a to the 5 squared equals a to the 10. Now notice that when you have an arrangement when you have a power raised to another power, as in the second power is outside of the bracket, you multiply these together. That's a difference of procedure for when you might consider adding them, but in this case you've got the bracket, so you must do 5 times 2 equals 10. So therefore a to the 5 squared equals a to the 10. Combining them gives you the correct answer of 16 a to the power of 10. Now we've got a few answers here that are wrong or partially correct, just checking that you know the law of indices. Now you can see with this option here, 16a to the 7, that would be correct if you were adding 5 and 2, but that's not the correct procedure in this particular question. 8 is if you have just done 4 times 2 rather than done 4 squared, and you can see that 8a to the 7 gives you errors in both the 4 squared and the a to the 5 squared, but the correct answer here is 16a to the 10. So this is a prime example of when you are looking at multiple choice questions, again, to work it out properly and then find your answer. Don't get drawn into their particular suggested solutions which may not be correct at all. Question 4. Y equals 10 over x. If the value of x doubles, what happens to the value of y? Circle your answer. Now, there are two ways you could approach this depending on how familiar you are with the concept of proportion. Now, you could very easily substitute values of x in, get a value of y, double the value of x, and check what happens to the value of y with regards to whether it's doubled or halved or times by 5, etc. But the best way to approach this is to recognise that y equals 10 over x is actually a form of inverse proportion, and that could be represented like this here. So this section just here represents y is inversely proportional to x. In that case, whatever happens to x, y will do the exact opposite. Now, they've already told us that x doubles, as in x times 2. We just said that y will do the exact opposite, so y would have to divide by 2. So divide by 2 is the correct answer in this question. Now, if you had tried some values and you weren't happy just taking that at face value, and you were only going to be convinced if you'd actually seen some numeric values, you could try x equals 1, which would give you 10 over 1, which is just 10. And then you could try x equals 2, as in you've just doubled it, and you'd have 10 over 2 equals 5. So you could see then that the y values had gone from 10 to 5, and that would also tell you that it's been divided by 2. But this, as a general formula, is an inverse proportion. The correct answer is divide by 2. Question 5a. Factorise x squared minus 100. Now, anyone doing a GCSE higher paper should always be on the lookout for this particular expression, either in isolation as it is here, or as part of a larger expression. This is an example of the difference of two squares. So it's given away by the fact that you've got a square number here, x squared. Doesn't have to be a number, can still be a letter or a variable, and 100, which is the square of 10. So you've got to always be on the lookout for that, because it can appear in some sort of random location or asked directly, as you've got here. Either way, when you are dealing with it, they get factorised into the same format. They are always a bracket pairing, as we've got here. You just square root each component, so the square root of x squared is x and the square root of 100 is 10, and you add each of those into the brackets as shown and just put a plus or minus sign between each of the terms in the bracket. If you multiplied it out, you'd see that the plus 10x, which you'd obtain from that times that, and the minus 10x, which you would obtain from that times that, would both cancel out. So that's one of the characteristics of difference of two squares. But just be on the lookout for it. They don't always ask it directly. It can be disguised in an overall question. So the correct answer is just x plus 10, x minus 10. Question 5. Solve the inequality there. Now, when you're solving inequalities on a higher paper, there are two particular scenarios you'll get. One of them is solving a linear inequality, and the other is solving a quadratic inequality. They're very easy to recognise, as in this case, because you just look at the highest power of x that you've got. Now you can see in this particular inequality that x is just to the power of 1, so that just means it's a linear inequality, in which case you're only going to have one particular inequality in your answer. You're not going to have combined inequalities or an entire interval, which can happen in the other quadratic scenario. We solve inequalities in the same way we do equations, but there are two golden rules you've just got to remember when you are solving inequality problems, and that is, if you multiply or divide by a negative number, you must flip the inequality sign. And if you take reciprocals of both sides, and that just means that you would flip both sides. So if you had two fractions either side of the inequality symbol and you flip them, you would have to flip the sign then. So just be aware that that can arise at some point in the paper. In this case, all we've really got to do is start rearranging it until we get x to be the subject. So it's really testing that you can successfully rearrange values. So the first operation to do is note that the 7x has got the most x's on, so I decide I'm going to take away 2x, so we get 5x plus 6 is greater than 1. Next thing to do is consider that, well, I've got the x's on this side, so I want the numbers on the right hand side. I need to subtract 6, which we do as well, so we get 5x is greater than negative 5, and then because it's the same procedure as solving, in that case you need x in the singular on its own, divide it by 5, x is greater than negative 1. your answer must be all of that in its entirety. X is greater than -1. Don't just write -1, because an inequality is not an equation. You're not finding a particular value. You're defining a range of values. So the correct answer is to write in its entirety, X is greater than -1. Sometimes students decide to write equal signs here, but that does pose its own risk in the scenario where you do have to flip the sign. So although we are approaching it in the same way we would as if it was an equation, make sure you maintain the inequality sign as you go from operation to operation until you get the correct answer given here. Question 6. Work out the value of √3 squared times √2 squared. Now, square rooting and squaring are opposite processes, so if you apply them simultaneously to a number, in this case 3 or 2, then it's as good as not actually doing anything at all. It would be the same as saying add 5, subtract 5, or times 2, divide by 2. Effectively, you've done nothing. So the square root of 3 squared would actually just be 3, and the square root of 2 squared would actually just be 2. So the overall calculation is just 3 times 2, which equals 6, as we've got there. Question 7. Here is a quarter circle of radius 6 centimeters. Work out the area of the quarter circle, give your answer in terms of pi. The general area for a full circle would be pi times the radius squared. You will use that formula here, but you've got to remember that you've only got a quarter of a circle, so when you do calculate pi times radius squared, you've got to make sure you divide it by 4. It's worth always stating that at the start when you are processing the actual calculation. So here we've got area equals pi r squared over 4, and then you've just got to make sure you substitute the correct value into the formula. The only variable in this formula is the radius, but that's directly stated as 6 centimeters. 6 squared is going to be 36. Divided by 4 will be 36 divided by 4, which is 9. It says give your answer in terms of pi, so do not try and approximate what pi is in any format at all. Just leave it as pi wherever it appears in your actual answer. So in this case it's equal to 9 pi. Now there are several options in the way you could express that. You could have 9 pi, that even allow you to have pi 9 written as an actual answer, or 9 times pi, or pi times 9, but the proper and correct procedure to write it down would be to have the actual number in front of the pi. So 9 pi should really be what you wrote in your answer. Question 8. 3 whole numbers are each rounded to the nearest 10. The sum of the rounded numbers is 70. Work out the maximum possible sum for the original 3 numbers. Now, notice that they've actually put whole numbers. They've written that in bold. There's a reason for that. That's to tell you that first of all you're only dealing with integers, but it's also got implications for the way you consider how you would round the number. Now, regardless of whatever number you're dealing with, whenever you round an integer to the nearest 10, the actual integer itself can have a maximum value where the end digit is a 4, and it would still round to something that ended in 10, let's say, or it could end in a 5 and then it would round upwards to something that ended in a 10. So for instance, if I had 94, that would round down to 90, and if I had 85, that would round up to 90. The point being, 94 would be the largest value I could actually have that would actually round down to make 90. And that restriction's relevant here because your 3 numbers, when they are rounded, have all got to add up to 70. Now, you can make up any 3 such values that satisfy that requirement, and then make sure you've actually added up what their original value would be to get the total. So for example, you could go for 20, 20 and 30 because they all add up to 70, but that's after they're rounded. Now notice that each one of them before it was rounded would actually have been 4 units larger, 24, 24 and 34. The point being that each number is always 4 units larger, and it didn't matter which values you actually picked to add up to 70 in the first place. You could have had 10, 20 and 40, 50, 10, 10. Regardless of the combination, they would always be 4 larger for each value. So overall, you're really increasing your original total of 70 by 4 times 3. 4 times 3 of course is 12, add that to 70 and you get 82. So it would make no difference at all what you actually tried for the combination of the 3 numbers. It's worth also looking at the alternative in this question, because they could have easily asked you what is the minimum possible sum of the original numbers, in which case each number would end in a 5. So for example, let's say we had 15, 15 and 25. Now if they were all rounded to the nearest 10, we'd get 20, 20 and 30, the same values that we had here. But the original numbers in this context would add up to 55, which is 70 minus 3 times 5. It's always worth remembering when you are actually asked to give values, when you're dealing with a boundary problem such as this, when you're dealing with the rounding, always try and check whether you're dealing with a continuous value or a discrete value. Now if you're dealing with integers, whole numbers or anything to do with counting, you're dealing with a discrete value, so there will be a particular value that you can write down as your upper limit. Our upper limit, because they were all integers, was just 4 units larger than whatever rounded value you had, so 24, 24. Of course, being an integer, you couldn't have 24.5 or anything like that, even though technically that would still round down to 20. So you've just got to watch out for that when you're actually dealing with an applied use of an upper bound, which is effectively what each of these are. Either way, regardless of the 3 numbers that you pick, that you ensure add up to 70, the answer will always be 82, and it's 82 which is the correct answer to this question. Question 9. Circle the expression for the range of n consecutive integers. So n in this case is referring to the number of integers that you've got, not necessarily a particular value, just the number of objects that you've got in the collection. Range means that you've got to find the difference between the upper value and the lower value, and consecutive means that the numbers will come one after another. With these problems, they're often questions that you've not necessarily considered, so it's often worth investigating to check what kind of pattern emerges when you do check what the range of n consecutive integers actually are. So if we say look at n equals 2, and of course that does mean the number of integers, not the number 2. So for instance 3 and 4, that's 2 consecutive integers, their range is just 1. 4 minus 3 is 1. If we look at n equals 3, as in 3 consecutive integers, 5, 6, 7, the range is 2. 5 is 2 away from 7. And if we look at 4 consecutive integers, 8, 9, 10, 11, you've got 11 minus 8 equals 3. So there's enough here to establish a bit of a pattern. You can see that whatever value you've got for n, here 2, 3, 4, the value for the range is always 1 less than the value for n. Well, that's enough to establish a pattern and state the correct answer, which would have to be n minus 1. Question 10. 3 identical isosceles triangles are joined to make this trapezium. Each triangle is base b centimeters and perpendicular height h centimeters. Of course, it's not drawn accurately. You've got the side here b and the perpendicular height h there. Work out an expression in terms of b and h for the area of the trapezium. Give your answer in its simplest form. There are 2 ways you can tackle this problem. You can either say, well, there are 3 identical isosceles triangles here, so all we really need to do is get the area of one such triangle and multiply it by 3, or you can apply the trapezium area formula and substitute the relevant values in directly. Now, because all of these triangles are identical, that means that this side here and this side here has also got to be of length b centimeters. The height, of course, is shared with all 3 of them. So if we go ahead and use the area of a triangle to begin with, we can say that each triangle has area a half base times height, which will just be a half bh here. All we have to do then is multiply it by 3. So 3 triangles is 3 times a half bh, which will be 3 over 2 bh, which would give you the formula there, or what we should correctly say, the expression for the area of this actual trapezium. Now, if you were going to use the trapezium method, you could have said, well, there's the shape of the trapezium. This side and this side are the 2 parallel sides. So in terms of the trapezium area formula, these 2 parallel sides form A and B. Now, h is the perpendicular distance between them, so all we have to do is substitute the values into the equation. So the trapezium area is a half h, a plus b, a half h, b plus 2b, b there, 2b there, which becomes 3b on addition, and therefore it's 3 over 2bh, giving you exactly the same answer as you had before. So either way, you get the same answer. You do have to know the trapezium area formula. It's not a provided formula in any sheet in the exam, so be prepared on a higher paper that could crop up somewhere in a question where you really do actually have to use it. Either way, correct answer 3 over 2 BH or 1.5 BH, so any equivalent format. Question 10b. This diagram shows the same trapezium. Now notice in this particular question that they've also added the side slant length here of S this time. We've still got the same length B though. We're also told that the ratio B to S is 2 to 3. We need to work out an expression in terms of B for the perimeter of the trapezium. So they want the distance all the way around the outside. They also want this expression to only contain the term B. Now that initially seems to be a problem, because if you were to write the perimeter down, you could see that the distance around each of these sides is definitely going to involve S. To get rid of that, we have to utilize this ratio here. Now, an important technique that you need to be aware of when you are dealing with either a higher or a foundation paper is how to use ratio cross multiply. Now all that really means is, how do we have a ratio and convert it into a usable equation? So all we do is this: we write the two ratios down. So in this case, B to S is 2 to 3, so I just write them in a vertical alignment as we've got here, and you cross multiply them. So 3 times B, so 3B, is equal to 2 times S. So you can use that to very quickly obtain an equivalent form in an equation. So just here's another example of it. So if we had x to y was 7 to 10 and we had to write that down as a ratio, we would get 10x is equal to 7y. So that was just a random example, but cross multiplying a ratio is a very important skill that you are well worth learning, just in case it crops up in any particular problem, and it's very diverse, the type of problems that could occur in. So now back to the actual question of calculating or writing an expression for the perimeter. The perimeter initially will be 3b plus 2s, so b, b and b, so 3b, and then you've got s there and s there because all these isosceles triangles are identical. But we already know that 2s from here is equal to 3b, so all we do is replace it with 3b. 3b plus 3b is 6b. 6b is the correct expression. Question 11. The 4 candidates in an election were A, B, C and D. The pie chart shows the proportion of votes for each candidate. Work out the probability that a person who voted, chosen at random, voted for C. Okay, so first thing to note here is we have a complete pie chart with all the sections labelled. Of course, it's never drawn accurately, so you can't just get a protractor and measure angles. You've got to use algebra to actually solve this problem. Now, a pie chart is all about showing proportion. It's a visual representation of what a ratio shows you. So all the kinds of rules that proportionally relate ratios technically are the same as what would be shown in a pie chart. Remember that a complete pie chart is going to be out of 360 degrees, and it's that fact that we can use to actually begin answering this problem. Now, notice they didn't say at all what any particular section was with regards to its angle. We do know that A is 90 degrees, but we do actually have algebra terms or expressions for each of the other sectors. All we've got to do is add all of these up and equate them to 360. So by doing that, we're effectively solving for x to begin with. So 2x plus 10 plus 2x plus x plus 90 must equal 360. Collect the terms on the left hand side. 2x plus 2x plus x is 5x. 10 add 90 is 100. Subtract the 100 from both sides. 5x will equal 260 and divide by 5. If you ever have to divide by 5, just divide it by 10 and then multiply it by 2. So you can get 26 and then double it to get 52. Of course, you might already just do that mentally anyway, but it doesn't really matter. Either way, x is equal to 52. Now, the probability that a person who voted for C is the same as the proportion that the C sector makes up of the entire pie chart. So in other words, what proportion is 2x plus 10 out of 360 degrees? And that's what you're trying to answer. So probability and a proportion mathematically are actually identical. Well, we already know what x is, so we can use that to find out what 2x plus 10 is. So substituting x equals 52 in, 2 times 52 is 104, plus the 10 is 114. This means that our probability of a person voting for C will be 114 out of 360, as in the sector angle for C, which is 114, divided by the total angles in the circle, 360. Now, that technically is acceptable as an answer, but 114 and 360 both have 6 as a factor, so 19 out of 60 could also be written down if you wanted to fully simplify it. So it's always worth bearing in mind with a pie chart that you can approach it in the same way as a ratio. You're not always given a means by which to equate the entire angles in the pie chart to a particular value. You might only be given a section of it, but either way you just equate it to the angle in the section. In this question they wanted you to recognise that probability and proportion are the same, so 19 over 60 is the correct answer. Question 12. Use approximations to one significant figure to estimate the value of this. You must show your working. Okay, so remember, when you are rounding a number to one significant figure, you are reading left to right, and you only start counting significant figures when you've gone past all of the zeros. So that is a common thing that they test you on in this particular question. Now you can already see they're doing that with 0.526. So a common error here might be to say, well, that will just round to 1. It will not do, because one significant figure actually refers to the 5. That's the first significant figure there. The others are more straightforward. Now, when you are rounding to one significant figure, the place that you are doing the rounding is variable because it depends on what number you're actually looking at. It's not like decimal places or to the nearest 10, say, where there'll always be a fixed position regardless of what the number actually is. With 0.526, the dividing line will go between the 5 and the 2, because 5 is the first significant figure. The divider always goes after that. 2 itself is less than 5, so this becomes 0.5. For 39.6, the divider goes after the 3. 3 is the first significant figure. 9 is 5 or greater, so this would round up to a 4, 40. For 97.65, 9 is the first significant figure. Put the dividing line in. 7 is 5 or greater, so 9 rounds up by 1, which makes it a 10 in effect. Therefore, that becomes 100. You always have to put zeros in up to the decimal point. You can't just say that's 10, because that's completely different with regard to its size of magnitude of the number from what it really should be. So we have 100 there. Now all we do is replace all of the original values with their now rounded value equivalent. So it will be 0.5 times 40 squared divided by the square root of 100. 40 squared, well, if you just think of 4 times 4 is 16, and then there'll be 2 extra zeros because it's 40 times 40. Add those 2 zeros on, 1,600. The root of 100 is just 10. Next thing to do is just consider, well, 1,600 divided by 10 is just 160. So the whole calculation is just 0.5 times 160. Multiplying by 0.5 is the same as halving a value. The answer is 80. And when they say you must show your working, at the very least they needed to see the part on the right hand side here. They wouldn't have been too fussed about you directly writing this down, because this was implied by what was substituted into the positions on this side here. This is only to illustrate where the actual dividing boundary is, but do remember that you do not count zeros if they're the first digits you encounter when rounding to any number of significant figures. Zeros will only count if they have come after other non-zero digits. So for instance, if this number here was changed to 0.5 and then there was a few zeros after that before the 2 and the 6, the zeros after the 5 would be counted in the significant figure totaling because they came after the 5. That wasn't so much an issue here. What they were really checking is that you didn't miss the fact that you put the dividing line here. That's the only real sort of pitfall with this question, and whenever they do get you to round these, you often have to make sure you've watched out for that. Sometimes you get questions where they want you to do a rounding and they don't actually give you a degree of accuracy to do the rounding to. So if it's unguided, in that case you are better off always rounding to one significant figure, mainly because the numbers might be too cumbersome to deal with and it's usually adequate for what they're actually after in the question. The correct answer is 80. Question 13. X to y equals 7 to 4, x plus y equals 88, work out the value of x minus y. Now sometimes questions that would ordinarily be quite simple are asked in unfamiliar ways. Now all this question is really saying is that you have these two components x and y that can be divided into a ratio of 7 to 4 and that their sum is actually 88. So it's really saying just divide 88 into the ratio 7 to 4. Now when dividing a ratio, if you sum the parts, 7 add 4 is 11, that means 11 parts must be 88. Dividing by 11, one part will be 8. So you can now work out respectively what x and y are. We only need to work out what x minus y is, but we still need to know what x and y are individually. X will be 7 times the 8 because x was 7 parts, which is 56. Y is 4 times the 8, y was 4 parts, which is 32. The value of x minus y will be 56 minus 32, which equals 24. Now you could have looked at that. If you didn't want to actually work out what x and y were individually, you could have just said, well, x minus y just means the difference. The difference can also be looked at in terms of parts. 7 minus 4 has a difference of 3. So you could have, at the stage where you had one part equals 8, just found that 3 parts were equal to 24. Either way you get the same answer. So all that we're doing in this question was trying to ask what was ordinarily a regular question, because you might just say in general divide 88 into the ratio 7 to 4, but they didn't want to word it that way or write it that way, so they've done it in a more unconventional fashion to check that you've recognised that it's still just the same thing. Correct answer is 24. Question 14. Two congruent regular polygons are joined together. Not drawn accurately. Work out the number of sides on each polygon. Now congruent means they're absolutely identical. Regular means that all of their angles and sides are also identical. Now they've been joined together along this common side here, and what you have to consider is that this common side can actually be extended out, and because these two polygons are congruent, if this line is extended out, it will bisect the angle of 60 degrees, in other words cutting it in half. Now also of note is that if you do extend that line across there, it means that the exterior angle of either of these polygons is actually going to be equal to 30 degrees. Now when you're dealing with a regular polygon, you know that all the exterior angles are going to be equal, and that all of the exterior angles will always sum to 360 degrees. So if you know how many exterior angles you've got, you effectively know how many sides you've got as well. Now the exterior angle of each individual regular polygon is 30, so the number of sides will just equal 360 divided by the exterior angle, which is 30. Now dividing 360 by 30, you just cancel the two zeros out there, it's 36 divided by 3 equals 12. So both of these regular polygons are 12-sided shapes. 12 of course is the answer. They only actually expect you to know the worded description of a polygon up to 10 sides, which would be a decagon. A 12-sided polygon will be a dodecagon, but it's not required knowledge. No further than 10 sides is required. So the correct answer is 12. Question 15. Meal deal. Choose one sandwich, one drink and one snack. There are 7 different sandwiches, 5 different drinks and 3 different snacks. How many different meal deal combinations are there? Now this question is an example of what we call the product rule for counting, and all that means is to sum all of the different combinations, you just have to multiply the number of objects together in each different group. So there's 7 sandwiches, 5 drinks and 3 snacks. You're just selecting one of each, which would mean you have to do 7 times 5 times 3 to figure out the total number of combinations. So product rule for counting here, 7 times 5 times 3 is equal to 105. Now if you're trying to visualize what this is actually doing, if you were going to draw a giant probability tree out to show all of the different pathways that you could go down, in the first selection you would have 7 branches to select each sandwich. But on the end of each of those 7 branches, there would be another 5 different branches for the drink selection. And on the end of each one of those, you'd have 3 branches for the snack selection. Now, of course, this tree would be enormous if it was actually drawn out properly, not just a small sketch of it. But the 105 is significant because that would tell you how many end branches you would have if you drew the entire tree out. So that's what the product rule of counting is really doing. It's telling you how many end branches are there, how many pathways are there that you could travel down for all of these combinations. Now, how you recognize one of these questions is to consider when you're selecting one object. You can sometimes be selecting 2 objects, but for the moment let's just consider you're picking one object from each group, in which case you would just multiply those values together. Now, if you were, say, picking 2 different sandwiches and they had to be different, and you wanted to know, well, how many combinations could I do for that? Well, in the first pick you've got 7 options. In the second pick you've got 6 options, because we're assuming that you're not going to pick the same one again. So in that case you'd do something like 7 times 6 equals 42. So the main thing is to isolate the groups that you're actually selecting from. They've made it quite clear here with sandwiches, drinks and snacks, but you want to be able to recognise it anyway, just in case it appears in any other guise, because it can be anything to do with picking objects. You could have a team that you've got to make up and the selection order's got to be boy, girl, boy. That would be the same kind of problem, because you might have a class where you have so many boys and so many girls. Either way, you're picking from a group of people as you go, and you would apply the product rule for counting by multiplying the number of options you've got in each selection together at that time. Well, we're only picking 1 from each, which is why it was 7 times 5 times 3, which of course is 105. That is the correct answer. Question 15b. 2 of the sandwiches have cheese in them. 3 of the drinks are fizzy. Eva picks a meal deal at random. Work out the probability that the sandwich has cheese in it and the drink is fizzy. Now, it might appear that this is actually the same kind of question as you had before, where you were just multiplying the different options together, but it's not. This is about probability in succession, and all that really matters is the probability of picking a particular type of object at each selection. Now, the first object that you're picking is a sandwich that has cheese on it. Now, we knew from before that there were 7 different sandwiches and that 2 of them have cheese on them. Now, the probability of picking a cheese sandwich would therefore be 2/7. The second requirement is that the drink is fizzy. Now, we know 3 of the drinks are fizzy and there were 5 different drinks altogether, so there is a probability of 3/5 of picking a fizzy drink. It's actually independent here of what snack she picks, so you could actually think of that as, say, times 1, because it doesn't matter at all in this question. Now, because you've got to pick a cheese sandwich and a fizzy drink, that has to come in succession. Now, when you're dealing with probabilities in succession, you multiply them together. It's the same as considering going along the branches in a probability tree. As you progress across the branches, you must multiply by the associated probabilities on each branch. So we're just going to multiply 2/7 times 3/5. So remember, in multiplying fractions, multiply the 2 numerators together. 2 times 3 is 6. Multiply the 2 denominators together. 7 times 5 is 35. That can't be simplified anymore. The correct answer is 6/35. So that would be an acceptable form of the answer. They might accept a decimalised form, but be aware that that would technically be rounded. It's better practice just to leave it as a fraction in this case. Now, if you wanted to try and consider how does this probability connect to what we were looking at before, the key is to recognise that it would be like drawing another giant probability tree out, but this probability tree would actually end here because it was independent of the snack selection. So it didn't matter what branches came off the second selection, because the snack was always going to be picked. It was the cheese sandwich and the fizzy drink that mattered. Now, if we look at the branching up to this point, we'd got 7 selections here and 5 off each of the 7. 7 times 5 is 35. That's where the out of 35 comes from. But we're not picking all of the branches. Only 2 of the branches here would have had cheese sandwich as an option, and on the end of each of those 2 cheese sandwich options, only 3 of the branches at the drink selection would have been fizzy. So you can actually see that you'd have had 6, 3 there and 3 here if it were drawn, that would actually be appropriate for the selection of a cheese sandwich and a fizzy drink. That's where the 6 comes from. It's easier overall though just to consider this as a probability in succession, cheese and fizzy, as in multiply each of the probabilities separately. 6 over 35 is the correct answer. Question 16. Water is poured into a tank. The graph shows the number of litres of water in the tank. How much water is poured into the tank each minute? Circular answer. Now, first thing to notice with this graph is that it is linear. The number of litres is given on the y-axis and the time in minutes is given on the x-axis. Now, we're not actually told much about the dimensions of this tank, nor about whether the filling rate was constant. Now, even though we've got a straight line there, you could suspect that the filling rate might have been constant, but it's not necessarily true if the tank was shaped in a strange way such that you'd still produce a straight line like that. What really matters here is that we can find an integer intersection on the graph. Now, there's 2 such locations that we could use. We could look at 4 and 60 or 8 and 120. Either of them are going to generate the same answer. Now, by saying how much water is poured into the tank each minute, that's really the same as saying what's the gradient of this graph. It would have exactly the same implication. Now, if we look at, say, 4 and 60, you've got your height there, which is 60, and your base there, which is 4. So 60 divided by 4, rise over tread for a gradient, is 15. And 15 litres per minute will be the correct answer to this problem. So it's just another way of asking you to find a gradient. So they could have asked you that directly, and you would have just been able to find any particular point would have done on this line. Or they can ask you, what's the change in the litres for the change in the minutes, which is another way of asking for the gradient. So it's based on each minute. So in 1 minute it was 15 litres. 15 litres is the correct answer. Question 17. A and B are similar solids. Got a solid A and B with their lengths L and 2L in centimetres given in the table. Alex says the volume of B is double the volume of A because the length of B is double the length of A. Is he correct? Tick a box, yes or no, give a reason for your answer. Now, the first part of this statement is actually incorrect, but the second part, technically, part of it is correct. The length of B is definitely double the length of A. You can see that from the ratio in the table. If B is 2L and A is L, that's a 2-to-1 ratio there, so B is definitely twice the length of A. But similar shapes do not behave across dimensions, as in areas and volumes, is in the same way they would with lengths. The ratios can be found though quite easily just by considering the length ratio. Now the length ratio we already know is 1 to 2. If we want the ratio of the areas of the shape, so this would be any part of the shape, it could be its entire surface area or just a part of it, the ratio would be 1 to 4, and the ratio of the volumes of the shapes would be 1 to 8. Now these ratio values just come from the squares of the length ratios. So if you have 1 to 2 and you square it, you obtain 1 to 4, and if you cube 1 to 2, you obtain 1 to 8. So you can see there that as you go through the dimensions, length to area to volume, you have to either square or cube the length ratios to get the ratios in that respective dimension. So overall the answer is no. Is he correct is not true, and the reason is the volume ratio would actually be 1 to 8. Question 18. Circle the 2 roots of 2x plus 3, 5x minus 2 equals 0. Now, when roots are mentioned in this context, they're the same as thinking about what are the solutions. So we're really being asked to actually solve this particular equation. Now, overall, this would be a quadratic, and one of the ways of solving a quadratic would be to set it equal to 0 and then factorize it. Well, all this has already been done, so all we need to do now is process the information of the terms inside the brackets and then find out what the two solutions are. Now, the first bracket is 2x plus 3 equals 0, which can be rearranged to make x the subject. 2x equals negative 3, x equals negative 3 over 2. So negative 3 over 2 will be one of these solutions. 5x minus 2 equals 0, so 5x equals 2, x will equal 2/5. 2/5 would be the other solution. Now, if you were drawing a quadratic, then negative 3 over 2 and 2/5 on the x-axis would be where this particular quadratic crossed the x-axis. That's why they call them roots. They're the points where it crosses an axis. But in the context of the algebra, finding the roots of an equation and finding the solutions to the equation are identical in this context. So all you would do is circle negative 3 over 2 and 2/5. Question 19. The diagram shows a triangle and a trapezium. Prove that A equals B. For this proof, we need to use two geometric facts to establish equations that contain A and B somewhere, and then derive that the value of A and B will both be equal. The first fact we can use concerns angles about a point. Now, if we look at this point here, we can see that we know all of the angles about that point, and we know that this must sum to 360 degrees. If we look at B and C, we notice that they form part of the angles in this trapezium, of which this side and that side are parallel. That means that B and C are allied or co-interior angles and must sum to 180 degrees. So we have two equations now that we can write. Now, the first one, using angles about the point, A plus C plus 65 plus 115 must equal 360 degrees. So A plus C plus 180, because 65 plus 115 is 180. If you subtract the 180, you'll get A plus C equals 180. So that's the first equation. For the second equation, we can just state directly that B plus C equals 180 also, but underneath I've written allied angles. You must, in a proof, give reasons for your equations or deductions that you make. You can't just state something because they could interpret it as you just trying to fudge the answer. So the reason for that is because we have allied angles. Now notice that you have two equations here and both of them are equal to 180 degrees. Now if they're both equal to 180 degrees, then technically they're both equal to each other. We can say that A plus C must equal B plus C. 180, 180, both the left hand sides are equal. Since plus C appears on both sides here, just subtracting it gives us A equals B. So that result just follows on. And that black square just means that you've concluded your proof, that you've reached the end of it. So we've concluded our proof with A equals B. It's not immediately obvious that they would be equal to each other, which is why sometimes with angle problems you do have to write down effectively what you know and let the result get produced from that. The same goes for circle theorems also. If you're given a circle theorem, don't expect the immediate answer to be that obvious. You might have to add information or annotate the diagram before the answer can be deduced. In the same way you might approach a crossword. You add successive words in until other words become easier to obtain. So that's our proof, A equals B. You might want to add that this was just about angles about a point, but it's fairly self-explanatory in that case that 360 would have to be equal to the sum of these components. Question 20. In 1 month, the number of hours of exercise taken by 10 people are the following values. So you can see those there. 82 is anomalous in this case. It's significantly larger than all of the other values. That might be significant with regards to the rest of the question. Which is the appropriate average to use in this situation? Tick a box, so mean, median or mode, and give one reason for each of the other two averages as why they are not appropriate. Now, in general terminology, if you say find the average, we're usually referring to the mean. But in maths, when we're saying appropriate average, it actually is an umbrella term to refer to both the mean, the median and the mode. Now, if we consider how each one of those is calculated, it might give a reason as to why it's suitable or not suitable. Now, a mean would be calculated by summing all of the particular values and dividing by 10. Now, that's okay as long as the values are fairly symmetrical about, say, a typical point. Now, supposing I did add all those values up, now apart from 82, you can see that all of them are really 1, 2, 3, 4, 5, 6, 7, 8, 9, etc. So if you're just looking at the lower of those values, if you got a mean that was, say, around 5, that would be fairly typical of the data that you've got there. But with 82 being included in this, when you do calculate the mean, it's going to skew the value, so it's artificially inflated. Now, I use the word artificial in the sense that maybe 82 is actually an anomaly, but it does mean that any value of mean that you calculate there would not be that representative of all the other values that you've got. So if we calculated the mean and say we get a value of 12, well, most of the values are actually less than 12, and a mean isn't particularly good when most of the values are to one side of it. You want the mean to be really fairly typical and to be roughly in the middle of the values in your data for it to be a good representation. Now, the median is not affected by such problems as extreme values, because for a median you would just order the numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9 and then 82. The middle would just be between the 5th and 6th term. So the median effectively would be 5.5, and that would be fairly typical of most of the data. So the median, I would suspect, is the most suitable here. The mode is the most common. Now, the thing is with the most common is that's useful when a significant number of the data are actually equal to each other, but none of the data are equal to each other here. So effectively every number is the mode to render it useless, because it just returns every single value anyway. It would be particularly representative of your data. So all we have to say for this problem is that the median is the most suitable, and the reason we wouldn't use the mean is it's affected by extreme values, so highlight 82, and we don't use the mode because all the numbers occur exactly once here anyway, so it doesn't really tell you anything. Now, if you wanted to, you could go and calculate what the mean was and prove that it was extreme. It is a non-calculated paper, so it's not necessarily expected. You've just got to state that it's affected by that value of 82. So what's written there is sufficient to get the marks in that problem. Question 21. A, B and C are points on the axes as shown. The area of triangle ABC is 28 square units. Work out possible coordinates for A, B and C. Now, A, B and C are not defined precisely, and you can imagine them as actually being able to slide along the axes in their relative positions. The only rules that you've actually got to adhere to is that A and B are on the y-axis, and that A would have to have a positive y value and B a negative y value, and that C is on the x-axis and would have to have a positive x value. But apart from that, because they can go absolutely anywhere along these axes, there are infinite solutions to this problem. So as long as you've satisfied some fundamentals, i.e. the properties just mentioned about A, B and C, and that the triangle itself, when you calculate its area, is 28, then you will have a correct solution. Now, if I was looking at this, I'd be thinking, well, how do you get the area of a triangle? It's just a half base times its height, and we can use the axes to our advantage to get suitable values. A and B, if you just think of that as the base, so the distance between A and B, not their coordinates at this stage, just the distance, that can be considered the base. The distance OC can be considered the height. Now, if we start linking the area formula and the value of 28, we can start predicting what values of A, B and C might be suitable. So if we start with a half base times height equals 28, multiplying by 2 means that the base times the height must equal 56. So that's a rule that you've definitely got to adhere to. Now, all you've got to think about now is two numbers, and they don't necessarily have to be integers because they can be anywhere. It didn't tell us that multiply together to make 56. So let's just use 8 times 7, but you could have used 1 and 56, 4 and 14, 2 and 28, anything like that would have been suitable. Now, if we're saying that the base, say, is 8, then the distance between A and B has got to be 8, and therefore the distance from O to C has got to be 7. Now, since C is compared to the origin, that's effectively saying that we're going to let C equals 7, 0. So we already know what C is going to be. Now all we've got to do is make a decision on what points we want A and B to be at. The only criteria is they've got to be 8 units apart. So for example, we could let A be at 0, 6 and let B be at 0, -2, because 6 and -2 are 8 units apart, and there's C there as 7, 0. So this would be one such triangle that would be suitable in this scenario. Write down all the coordinates there. Don't mix up which coordinate goes with which axes, so you can see it's 0, 6, 0, -2, and then 7, 0 for C. But there are lots of options that you can have here. It's just the area requirement and the distances between the points that really matter. So that's just one of infinite solutions. Question 22. Here is some information about the miles per gallon of 60 cars. Okay, so you've got the miles per gallon X and the frequency, and we need for part A to draw a cumulative frequency graph. Now all cumulative frequency means is running total, so in the column provided here, you don't really need this one, you just write down the running total or cumulative frequency totals. 6 is the first one, 6 add 16 is 22, add another 28 is 50, add another 10 is 60. When you're drawing or writing out this column, make sure your final total is equal to the overall total, so you know you've probably got it correct. Now when you draw a cumulative frequency graph, the cumulative frequency will be on the vertical axis and the variable that's been measured, in this case the miles per gallon, will be on the horizontal axis. Now you do not know anything about the individual miles per gallon for any of the cars. All you know is the total number of cars that are in each interval. Now that has implications for how you draw and plot out your cumulative frequency graph. Now when you are plotting them out, you've got to make sure that you take the right hand value of each of these intervals here. Do not take the midpoint, don't take the lower value, you've got to take the upper value, because that's all that you can say for certain. For instance, by the time you've got to all the cars that do 60 miles per gallon, I know there's 22 of them. I don't have any idea about how many cars you've got by the time you get to 55, I only know the endpoints. So we plot the cumulative frequency against the right hand side or endpoints of each of these intervals. So the first one to note is at 50 and cumulative frequency 6. So that's actually this point here. You'll also note that we do know technically that no vehicle uses or consumes less than 40 miles per gallon. So that's why there's a cross here. Now sometimes in mark schemes this is optional. You can draw that there or you might not do. I would probably draw that there because we do know technically based on our data that no car did consume less than 40 miles per gallon. So we've got that there as well. Continuing on, for 60 miles per gallon we've got 22, so 60 miles per gallon 22, 70 miles per gallon 50, so 70 miles per gallon 50, and 80 miles per gallon 60, which takes you to the end value. So the marks for part A are just for drawing a smooth curve that goes through each of the points to the end there. So we've got that drawn there. These dashed lines are actually part of the next part of the question. So that's what your cumulative frequency graph should look like. 22b, use the graph to work out the interquartile range. Now the interquartile range is the difference between the upper quartile and the lower quartile, and the clue to the procedure here is actually in the word quart or quarter. Now the idea is that you can split the data up into quarters. Now in this case our total cumulative frequency is 60. Now if you were to split that into quarters, a quarter of 60 is 15. So 15 would be the position here of the lower quartile. 30 is sometimes called the middle quartile, but we actually generally call that the median. And 45, which is the 3/4 point, would be called the upper quartile. Now the upper quartile and lower quartile positions are what you find first. So they come from the cumulative frequency axis here. But the actual values as to what you would state for the upper and lower quartile come from the variable that's been measured here. So if we go across from each of the values, let's start with the upper quartile, which is at position 45, and this will be dependent upon the curve or line even potentially that you've drawn. So going down from there, we get approximately 68. So the upper quartile there is 68. The lower quartile, going from position 15 across and then down, is at approximately 57 or 56, depending on whether you get a ruler to draw it precisely, but there will be leeway in that. So the difference between these, 68 minus 57 equals 11. So that's one potential answer for the interquartile range. There will be a small amount of leeway depending upon exactly what type of curve that you've drawn, but when you do draw your curve, the marks will be based on the accuracy of your drawing. So the interquartile range is effectively the distance between these two values. Don't mix it up with the distance between these two. You use the cumulative frequency axis to find the positions of the quartiles, but the range itself, interquartile range, is the difference between these, the data values that you were actually measuring. So in this case 11, but you may have got 12 or 10 depending on what graph you actually drew. So you would get leeway, but it is based on your graph only. Question 23. The equation of a curve is y equals x plus 3 all squared plus 5. Circle the coordinates of the turning point. Now there's a very quick way here that you can actually get the turning point, but a couple of observations. First of all, this is a quadratic curve, and it's also in the complete the square format, where you have the square part here and the plus 5 which completes the square. Now the general rule of obtaining a turning point from such an equation of the form y equals x plus a squared plus b is that the turning point will be at negative ab. So you swap the sign of the term in the brackets and you leave the b term as it is. Now the term in the brackets is plus 3 and then outside plus 5. So we swap the sign of the plus 3, so negative 3, and leave the 5 alone. So the turning point will be at negative 3, 5. That will be your correct answer. So that's one of the advantages of completing the square. If you do have a quadratic graph equation and it's not in the form of complete the square, by doing so you could answer that question as to what the turning point would actually be. But as a general rule, if you've got complete the square format already given for a quadratic curve, swap the number inside the brackets and leave the one outside alone to get negative 3, 5. Question 24. Here is a cyclic quadrilateral. The ratio of x to y equals 5 to 7. Work out the size of angle W. Now this is based upon circle theorems, and in a cyclic quadrilateral the opposite angles sum to 180 degrees. So for instance, x plus y would equal 180 and w plus x plus 20 will equal 180. Overall, of course, we're trying to work out the value of w, but because w is connected to x plus 20, we'd need to know what the value of x was before we could get what w was. So we have to look at this connection here between x and y, because we already know their ratio is 5 to 7. Now x to y equals 5 to 7 is effectively saying 180 is divided into the ratio 5 to 7. So that should be the start point with working out the answer to this problem. Now if we look at x plus y equals 180, we can split it into 12 parts, 5 plus 7. If 12 parts are equal to 180, then one part is equal to 15. Now we're only really interested in the value of x, which is 5 parts. So 5 times 15 gives us an answer of 75. So we already know x equals 75. Now that we've got x, we can substitute it into this angle here and the relation between this w here to obtain the value for w. X plus 20 plus w will equal 180, but x is 75 as previously calculated. 75 plus 20 plus w is 180. These two sum to 95, and if you subtract that from both sides, you'll get w equals 85, which is the correct answer there. So it's just about dividing a ratio and knowing opposite angles in a cyclic quadrilateral add up to 180. Correct answer is 85 degrees. Question 25. 15 machines work at the same rate. Together, the 15 machines can complete an order in 8 hours. 3 of the machines break down after working for 6 hours. The other machines carry on working until the order is complete. In total, how many hours does each of the other machines work? Now, this problem is what we call variation, and it usually involves direct proportion and inverse proportion. What gives it away is the fact that you've actually got 3 variables in the problem, so they'll nearly always present themselves in this particular format. Notice that you've got machines completing orders in a given time frame, so it will nearly always present itself in that way. You'll have an object doing a job in a time period, so you could have bricklayers building houses and over periods of days. So whatever it is, something is doing a job over a time period. Now, what's really important with these is that you know how each of the proportions are actually related to each other, and by that, because we've got 3 different variables here, we're going to have different relations between if one changes, how does the other change. Now, if you think about it, because most of these problems are based on the real world, consider machines and orders. If you've got more machines, they're going to complete more orders. That would mean that machines and orders are directly proportional. They'll do exactly the same. If we consider orders and time, if you've got more orders to complete, it will take longer to complete the orders. So orders and time are directly proportional also. But if we consider machines and time, if you've got more machines, you're going to complete the order in less time. So machines and time are actually inversely linked. They will do the exact opposite. Now, once you've written the heading, machines, orders and time, you want to input the known initial information. 15 machines complete an order, well, one of them, in 8 hours. So 15, 1 and 8. And the rest of it is about following the proportions and, of course, the order that the question is presented in. So if we just think about what's going on here, all the 15 machines are going to be working for 6 hours. Then 3 of them are going to break down, which will leave you with just 12 working machines, and they're going to carry on until the job is actually completed. Now, depending on how confident you are with proportion, you can actually answer this question pretty quickly, but due to the large amounts of formats of this variation problem, we are just going to examine the full detail of how we obtain the final answer to this problem. So we've started with our input values, 15, 1 and 8. Now, what we know is that these 15 machines are going to carry on working, but they're only going to work for 6 hours before one of them, well, sorry, not one of them, 3 of them break down. So we try and only change one thing at a time. So notice 15 is left alone because those 15 machines have carried on working for the first 6 hours. It's the time that has changed. Now, how do you get from 8 to 6 is the real question. Well, that's just times by 3/4. The easiest way to figure that out, of course, is to divide where you're going, 6 by where you came from. New divided by old, 6 divided by 8 is 3/4. Now, we know that orders and time, as discussed previously, are directly proportional. So orders will also be multiplied by 3/4 as well. Well, 1 times 3/4 is 3/4. So we effectively know here that when the 3 machines break down, 3/4 of the order had actually been completed. So what we want to know now is, well, if you've got 12 machines left, how long does it take now to complete the remaining quarter of the order? But that actually entails 2 changes, because first of all, we've changed the number of machines from 15 to 12, and we've also changed the amount of order to be completed from 3/4 to 1/4. So we do this in 2 separate stages. So first thing to do, change the number of machines. They've gone from 15 to 12. So what multiplier have you used to get from 15 to 12? Well, it's where you're going, 12 divided by where you came from. 12 divided by 15, that's 4/5. However, we're changing the time that these machines work for now, and machines and time are inversely proportional. They do exactly the opposite. So you don't times by 4/5 on this side, you times by 5/4, which effectively is the same as doing the opposite. So 6 times 5 is 30. 30 divided by 4 is 7.5. So what this row here is telling you is that 12 machines can complete 3/4 of an order in 7.5 hours, but that's not quite the full picture yet, because we now make the final change. We only needed to complete 1/4 of an order. So note the machines this time are fixed at 12. How do you get from 3/4 to 1/4? Well, that's really just timesing by 1/3, 1 divided by 3 if you like. Now, orders and time are directly proportional, so we also multiply the time by 1/3 as well. 7.5 times 1/3 is the same as dividing it by 3, so it's 2.5. That's told us that the remaining 12 machines would have to work for a further 2.5 hours to get the job done. But the machine, or the overall question, has asked us how many hours does each of the other machines work, as in the originals that carry on all the way to the end. Well, we knew they'd already done 6 hours of work, so 6 plus 2.5 is equal to 8.5, and 8.5 hours is the correct answer. So this being a variation question, you must make sure that you can draw out a table like that and then implement the changes. It's something that you would, if you're really targeting the higher grades on this paper, higher paper, you must make sure you know how to deal with these. There is a lot of variation in these variation questions, but the correct answer for this one is 8.5. Question 26a. 0.7 recurring equals 7/9. Use this fact to show that 0.07 recurring equals 7/90. Now, the fact that they're expecting you to use is that 0.07 recurring is just 0.7 recurring divided by 1/10, or you could look at it as being multiplied by 1/10. So we can see here that 0.7 recurring to 0.07 recurring is times by 1/10, which would mean 7/9 times by 1/10 should effectively generate the given value, and that's all they want you to do here. So 7/9 times 1/10, 7 times 1, 7, 9 times 10, 90, gives you the required result. That's all they want you to do there. For part B, using part A or otherwise, convert 0.27 recurring to a fraction and give your answer in its simplest form. Now, the part A part would entail us actually splitting 0.27 recurring into two separate decimals. So notice you could write it as 0.2 plus 0.07 recurring. Now, we already know that 0.07 recurring is 7/90. We've already done that. That's the part A component. And 0.2 is just a fifth. So if we add those two fractions together, we effectively can get the required result. Now, we're adding two fractions here, so we really want a common denominator. Since 5 goes into 90, we'll write the first fraction also out of 90. Well, 5 is multiplied by 18 to get to 90, so 1 times 18 is 18. Now they've got the same common denominator. 18 plus 7 is 25, but 25/90, dividing both of those by their highest common factor of 5, is 5/18, and you do have to do that because they said simplest form. Now, it also said or otherwise in the question, so there were other options available. Now, the or otherwise that they're really referring to is the algebra method. So what we do is we let the original recurring decimal equal x. I mean, you could let it equal any letter you like, but x is what you'll usually see in a textbook. And what we're trying to do is we're trying to obtain two separate versions of this x value, and you're only allowed to multiply by powers of 10. So 10x, 100x, 1000x, etc. And what you're trying to find is two such decimals that after the decimal point are recurring, and secondly perfectly match up. So those are the two requirements you've got to meet. Now, if we look at the initial value of x, 0.27 recurring, this is not recurring in a repeatable unit because you've got 2 first and then you've got infinite 7s after. So using x is not going to be valid for this. But if we get 10x, that will just move the decimal point one place, so it becomes 2.7 recurring, and now we do satisfy the requirement such that the post-decimal part is a repeating unit, 7777 to infinity. Now we need another one. Well, if we times by 10 again to get 100x, we'll now get 27.777 going on to infinity. And you'll notice we have another recurring component, but it also perfectly matches the one above it. And when you've done that, you can now subtract them. So we're effectively doing this equation minus that equation. 100x minus 10x is 90x. And because these 0.7 recurring components perfectly match, when you do subtraction, they'll just cancel out. So that was the whole point of getting them to match and recur. But you've also then effectively got to do 27 minus 2, which is 25. Rearranging for x, dividing by 90, x is 25 over 90. Dividing by 5 again, because it's the highest common factor, you get 5 over 18. So often you'll end up using this one, or they might say use algebra to obtain the fraction in its simplest form of a given recurring decimal. But this question, they weren't that fussed about you doing that. They allowed you to deconstruct it in another way, so you can pick whatever efficient way you like, but either way you'll end up with 5 over 18. Question 27. There are 11 pens in a box. 8 are black and 3 are red. 2 pens are taken out at random without replacement. Work out the probability that the 2 pens are the same colour. Now they've said without replacement here, which means that the probability is actually conditional, and you'll have to modify your probabilities for the second pick. They've also said that they're going to be the same colour, so we're only really interested in 2 pathways overall here. You can either pick black black or red red. Now if you want to avoid any mistakes here, it's probably best to try and draw out a probability tree and then use that to obtain your answer. Now in the first selection, we know that 8 are black and 3 are red, so the probabilities of each will be 3/11ths for red and 8/11ths for black. But in the second pick, there will be 1 less actual pen to pick from, so all the probabilities will actually be out of 10. And if in this first instance we go along the red red pathway, we've also already picked a red pen out, so there won't be 3, there'll now be 2. So in the second pick that's a red, it will be 2/10. This here would actually be 8/10, but it's not necessary for the answer, so I've just omitted it there, we don't need it. This side here though, if we're going down the black black pathway, then originally you had 11, there will now be 10 pens. There were 8 black pens originally, you've already selected one, there will now be 7 black pens. The rule for going along the branches, so red red or black black, is to multiply the probabilities together. So the probability of red then red will be 3/11ths times 2/10. 3 times 2 is 6, 11 times 10 is 110. Now it's often tempting with these fractions to actually start simplifying that down, because you might get into practice with doing that. But occasionally, because you know you're going to be adding fractions together, it's not always worth doing that at this stage. The simplification part should probably be done at the end. So just bear that in mind. It's not always best with these to just simplify immediately. Looking at the other pathway, picking a black pen then a black pen, that will be 8/11ths times 7/10. 8 times 7 is 56, 11 times 10 is 110. So the overall probability of picking the same colour will be the sum of this 6 over 110 and 56 over 110. So adding those together, they already have the same denominator, will be 62 out of 110, which you can then simplify down if you wish to 31 over 55, which is the correct answer. So without replacement is a bit of a giveaway for it being conditional probability, and by conditional, the probability of the second event or second pick in this circumstance is dependent upon the first. So on a higher paper, it's very likely that probabilities you deal with, particularly at this stage of the paper, are going to be conditional. And because you're only really making 2 selections as you go, a probability tree is the better way to present the data. So 31 over 55 is the correct answer. Question 28. A, B and C are points on the circle x squared plus y squared equals 36 as shown. A is on the y-axis, B is on the x-axis, M is the midpoint of AB, COM is a straight line. Part A, show that the coordinates of A are 0, 6. Now, when you're dealing with circles at GCSE, when you're certainly dealing with the equations of them, they will be confined to the origin. Now you know that because the equation starts x squared plus y squared and only x squared plus y squared. So if it starts with that, you know you're dealing with a circle whose centre is at the origin. The general equation of a circle is x squared plus y squared equals r squared. So r squared, where r is the radius, is equal to 36. Now if you square root 36, you will get 6. So you know that the distances from the centre O to any of the points on the circle, so it doesn't really matter whether they're on the axes or not at this stage, they will all be 6 away from the origin. Now we know that A is actually on the y-axis, so it must have the coordinates 0, 6, because the radius is 6, and any description of how you deduce that will be sufficient for getting the mark there. Now you could also have plugged in 0, 6 and showed that it satisfied the equation, and that was also credited with marks also, but you want to really be at the very least showing this section here about where the radius squared is the 36. We now also for part B have to work out the coordinates of B. Well, it's the same idea again, only B is on the positive x-axis, so B will be at 6, 0, 6 across, as in the x coordinate comes first, then the y. For part C, it says show that the equation of the straight line passing through C, O and M is y equals x. So they're saying show that this line here is y equals x. Now we were told that M is the midpoint of AB. Now we already know what A and B are, having just determined those from the previous two parts of the question. So M is just going to be the exact halfway mark of each of those distances. Well, B is 6 away, so that means that M will be 3 in that direction. A is also 6 away, so M will be 3 in that direction also. In other words, M is at the point 3, 3. Now O is at the point 0, 0, so those 2 points will be sufficient now for us to get the equation of this line. Now the equation of a straight line is always going to be y equals mx plus c, but we already know it goes to the origin at O, so we don't really need to worry about the plus c because it's 0 anyway. Now if you look at the point M, which would just be here, we've already determined that it's 3, 3, that's its coordinates. The gradient is just the rise divided by the tread, 3 divided by 3. We already know it's positive because of the direction of the line. 3 over 3 is equal to 1. So using y equals mx plus c, M is effectively 1. Therefore, you'd have y equals x for that straight line. You don't need to prove where C is at the moment because they already told you COM is a straight line, so by definition C would automatically be on y equals x, but we've already proved it by obtaining the gradient and knowing that the y-intercept is the origin. It's just y equals x. Now for part D it says work out the coordinates of C, give your answers in surd form. Now C itself, being on the line y equals x, will actually be making an angle of 45 degrees with either of the axes here. So that angle there, or that angle there, depending on which one you want to use, they're both going to be 45 degrees. The other consequence of that is that the x and y values that you use for their coordinates are going to be the same size. So all we really need to do is examine the triangle now. So here's the point C, that's the origin just there. Now the x and y coordinates, the x distance is that distance there, the y distance is that distance there. Because of the location of C, which we can see here, both of the x and the y values are going to be negative, but all we're really interested in the moment is the actual magnitude or size of those values. So we can do that by either using Pythagoras or maybe just some trigonometry. So here's the trigonometry method. So let's label this as 45 degrees as discussed earlier. This side is the opposite, that side is the hypotenuse. So we can say sine 45 is opposite, which is y, over hypotenuse, which is 6. So therefore y being made the subject is 6 sine 45. Now you do need to know your exact trig ratios for the higher and foundation papers. 45 degrees is one such angle that you need to know the ratio for. Sine 45 is root 2 over 2. So y is equal to 6 times root 2 over 2, which is just 3 root 2. Now, we know that the y value had to be negative, so the y value is also negative 3 root 2. And we knew that the x value was also the same size and negative, so that's also negative 3 root 2. So we do have our answer there also. Now, if we wanted to say just use Pythagoras and avoid the need for any kind of trigonometry where we needed to know an angle, remember that because we know that x value and that y value there are equal, you can just set them as such. So let y here also equal x as well. So using Pythagoras, a squared plus b squared equals c squared. X squared plus x squared is 36. We know that, of course, from the radius. 2x squared is 36 divided by 2. X squared is 18. X will be the square root of 18, which in simplified third form is root 9 root 2, but root 9 is just 3 root 2, which has the same implications as to what x and y are as before. So we obtain negative 3 root 2, negative 3 root 2. They were quite flexible on what format of the answer they wanted you to give that in, but this would be the standard procedure, maybe the best practice if you like, as to how to represent the coordinates of C. Question 29. Here is a sketch of y equals sine x for negative 360 to 360 degrees. For A, write down the coordinates of P. Now, the sine graph is periodic every 360 degrees, which means it completes a full cycle every 360 degrees. So if this is 0 degrees here, this point here will be 360 degrees. So one full cycle is one complete wavelength of the sine graph. P is located at the exact halfway mark, which would be at 180 degrees. Since it lies on the x-axis, it will also have a y value of 0. It's also worth noting that the sine graph and the cosine graph, for that matter, will oscillate between positive 1, which would be at the peak of this maximum here, and negative 1, which would be at the trough of that minimum point just there. So for question B, when you're asked to write down the coordinates of Q, which is at the top of one of the maximums, that will be at a height of 1, but because it's in the middle of this particular curve zone here, this location will be negative 270 degrees, where this point here would be negative 180. So the coordinates of Q are negative 270 degrees, 1. Question 30a. Work out the value of 81 to the negative a quarter. Now, when you have a power that has a negative in front of it, that effectively is referring to the reciprocal. So you can rewrite 81 to the negative a quarter as 1 over 81 to the quarter. So the negative can be removed by taking the reciprocal of the original number. So in this case, 81's reciprocal is 1 over 81. When you have a power of a quarter, that's really referring to the fourth root, as in what number times itself on 4 separate occasions would equal 81. Now on this non-calculator paper, it's worth noting that to obtain a fourth root, it's really like taking the square root and then square rooting again. The square root of 81 is 9, the square root of 9 is 3, so the fourth root of 81 will be 3, meaning that the overall value will be a third as shown below. Part B. Write 16 times 8 to the power of 2x as a power of 2 in terms of x. Now all this means is that the base value must be 2 and the power will have some other expression that contains x in it. Now 16 and 8 are both in the power series of 2, so that's the first thing to deal with. 16 is 2 to the power of 4 and 8 is 2 to the power of 3. So we can rewrite 16 times 8 to the 2x as 2 to the 4 multiplied by 2 to the 3 to the power of 2x. Now when we have brackets with the laws of indices, we multiply the two powers together. So you'd have 3 times 2x here, which produces 6x as shown on the new power here. So overall it's 2 to the 4 times 2 to the 6x, but using the law of indices again, if you're multiplying numbers and the base is the same as it is, because it's both base 2, you add the powers together, so you obtain the final result 2 to the power of 4 plus 6x, which is the correct format as requested here.